Okay, so speaking of, we were just talking a little bit about geometry. And we're actually going to talk a little bit more about geometry. What would be the area of the shape? Yeah, x squared. X squared, right? So x times x is x squared. Good. Now let's draw another square, okay? And this time, the side length is x plus 5, and it's a square, so this is x plus 5. I mean, obviously, all the way around is x plus 5. Yeah, every single side is x plus 5. But that's a different question. That's perimeter. That's for Math 60. We're in Math 65. So now we're talking about area. So you already told me the area of this piece right here is x squared. Does everybody agree with that? Yes. And what is the area of this piece right here? 5x, just 5 times x, right? And the area of this piece down here would be also 5x, good. And this last piece here, 25. Does everybody see how we got 25 on the last one? That's the easiest one, right? 5 times 5. Okay, and now, so the area is this plus this plus this plus this. Well, these are like terms. So I have x squared plus how many x's? 10x plus 25. And if we were saying it was x plus 5 feet, just for fun, just to go back to that idea, feet, then we would have feet squared. That would be our units if we were using units. But we're not really, because it doesn't say in the problem. I'm just emphasizing the point about square units when you find the area. Okay, now it's saying to expand and simplify this problem here. What does it mean when we have an exponent and it says expand? What does that mean? Write it times itself, right? Expand the exponent. So x plus 5 squared means x plus 5 times x plus 5. That's what it means to expand the exponent. And that's what I've been encouraging you to do. If you ever feel like you don't know the laws of exponents that we learned earlier on, 6.1, then always expand. Prove the rule to yourself. You know what I mean? Don't just guess, because then you have less and less chance of getting it right. Does that make sense? So when we expand it, we want to FOIL it. And do you remember FOIL? First, it's going to be, actually I'll write it here. First, x times x is x squared. Outside, 5x. Inside, 5x. Last, 25. Don't I get the exact same thing? I do. X squared plus 10x plus 25. Now we have this formula right here. So formulas are really nice, but they're only really nice if we can understand them. This is the formula for what we call a perfect square trinomial. And in fact, this right here is called a perfect square trinomial. Okay, or a PST. One of my students made that up. I liked it. PST. Perfect square trinomial. Why is it a perfect square trinomial? Because the original shape was a perfect square, and what the result I get is a trinomial. So here, this formula that I kind of wrote over is the formula for a perfect square trinomial. I'll show you how it works. So it says if we have x plus 5, then in the formula, x is equal to a, and 5 is equal to b, just meaning I'm going to have two different numbers there, okay? What the formula is saying is square the first one, that's x squared, so a squared. Now multiply 2 times a times b. A is x, b is 5. 2 times a times b, okay? And then plus square b squared, or square b. So 5 squared. What do I get when I simplify that? Same answer, x squared plus 10x plus 25. So it's just, this is all going to show you that, you can use this formula for the perfect square trinomial. Always when you see, a number times itself, oops, I meant squared. Oh, I forgot my squared. It's just like, they're like, what are you doing? So you see I have a binomial squared. The reason why this is so important is because people make a lot of mistakes. This is the most common mistake, and I see this even in Math 95. I see this mistake all the time, where people want to say, okay, a plus b, if I square it, that should just be a squared plus b squared, right? Is that true? Well, we've just proved 3 times that it's not true, because we have to FOIL. So let's say we make up some numbers for a and b. Just give me any numbers that you want to make up. 5 and 7. I'm going to correct the 7. I don't want it to be that big because I want it to be easier to add. Let's just do 5 and 1. 1 will work too. Okay, so we're saying these are not equal to each other, okay? So if I plug in 1 for A and 5 for B, and I square it, what do I get from that result? I would get 5 plus 1 is 6, and what's 6 squared? 36, okay? Now, if I said that's the same thing as 1 squared plus 5 squared, let's see, does that work out? What's 1 squared? 1. What's 5 squared? Oh, wait. 26. Is 26 equal to 36? No, they're not equal. So one of the biggest misconceptions is people see this and they think they can just square both of them. But what you're going to notice, if you go a plus b times a plus b, is that a times a is a squared, b times b is b squared, but what are we missing here? We're missing these 2 pieces, which are, this is AB and this is AB. How many ABs do we have? Yeah, so that's why it would be a squared plus 2 times AB plus b squared. So a lot of people will see the a times a plus b squared, and they will think that they can just square each one. But you can see from the diagram that you would be missing 2 very significant pieces of your square. You would only have half of it. Yeah? Did you have a question? Yeah. We would do that if it was multiplication. So you're getting it confused. Because I'm running out of room there, I'm going to go back up here. So let's say we have x, y squared, okay? To the 3rd power even. Here we're multiplying. So here we would have x to the 6, y to the 6. But the difference is here we're actually adding. And I can actually bring this back to an example that came up today in my Math 20 class. This is on fractions. And I actually think it would be good for us. We can always use more help with fractions. Everybody can. Because, 5 out of 4 people struggle with fractions, they say. Okay? So actually, I'm going to stop this for 1 second.